And today I've got Valerio, who has just completed the course ROS2 Basics using Python, and he'll be giving us a presentation on that. So what I'm going to do is to hand over the platform to him so he can begin his presentation. All right,
Okay.
whenever you're ready, Valerio.
Okay. Hello, everyone. Today I want to show you my project for the ROS2 Basics course.
Mm-hmm,
So I think I can start with launch the script, and I think I can move the robot in the middle of the environment.
mm-hmm,
Okay, yeah, I think here is like a good position. Yeah. Okay, I can launch the script. And we can see that the robots start to search the nearest point, and at the same time avoid the detect the obstacle, like so this red obstacle like a wall,
mm-hmm,
and after go to in front of the wall and start to align with the wall, and after we use the other control to follow the wall. This second control is very easy because it's just some constraint, and every constraint gives some control effort to engine. So yeah, it's very basic controller. And when the robot finish, so returning the start point, the robot stop and give on the terminal the path of the robot, so the point. And yeah, I think was the main task for this project.
mm-hmm,
Okay, yeah, we have a little lag. Okay, perfect. And yeah, the robot stop, and here give you the coordinate.
mm-hmm. Very nice. Yep.
Thank you.
All right. So take
Do
us.
you have some question?
Yeah, so take us, obviously, I'm going to ask a lot. I want you to take us through how do you get it to find the wall, right? And you can explain to us while um, looking at your code so that we get to understand the details of it and
Yeah.
which interfaces you used.
Mhm. So basic, I use this function find wall callback to find a wall, and every time that I call this function, I use this while cycle to find the nearest point. But before find the nearest point, I use this other function that I call filter to take just the valid range, because this filter function is a function that creates two empty lists, one with valid range and another with cluster. And we can see that I start to read every laser, and and I start to put each value of the laser in the cluster list.
Mm-hmm,
And after that, I put the laser in the cluster list. I start to compare the latest value with the current value. And if like I find a jump, so a gap of 15 centimeters, so I do the difference between the latest laser and the current laser. And if this difference is more than 50 centimeter, I like identify this different like obstacle, but or a wall, because after that I identify this like this jump, I see if this list is has more than 55 point, and if this have more 55 point, is a wall. Otherwise, it's an obstacle. And I don't put this laser in the valid range, but I put just the laser that is for me it's a wall.
mm-hmm. Why?
Naturally, this
Okay, why 55 points? How did you get to
because
that value?
with a lot of simulation, like this parameter is like it's not a perfect parameter, but it's just try and retry, because in fact if like the robot is too near to the wall, this obstacle is very
Mm,
near,
mm-hmm,
the function see that this is the wall. So for example, one solution can be like maybe the robot can go far from can go away from the wall, but that can be worked here, for example. but if like put the robot here in this narrow passage,
Yes.
the script doesn't work because it's too narrow. There is not a lot of distance. So I think I use just this simple function because in this way, if the robot is here, more or less I don't identify this wall like this obstacle like a wall.
Okay, okay. And did you, so on, I'm
Hmm.
assuming that on average you had a calculation that made you be
Yeah.
aware of how many indexes does that red block cover. Did you do that
Hmm.
check? And can you
Yeah.
tell me how your test worked? Where did you place the robot to do that check?
I create a script and after I cancel the script because was just my like my things. It's not was for the course, so I create a script to check with the laser. But after I remove this script.
Okay, yes, I understand that, but the reason why
Hmm.
I'm asking this is that what the span of indexes that that red obstacle will cover within your laser scan range, right, would be dependent on how the robot is facing that obstacle. That's why I was asking you when you
Yeah, 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 yeah.
used your script, right, where was your robot?
Hmm. No, 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 no. I don't use like the exactly position of the robot.
Okay, so explain to me a bit more. So how did you do it?
Like, sorry, can you repeat the question because I'm not sure about it.
All right, so maybe let's start from the number 55, right? The number 55, does it
Mhm.
refer to the indexes, right? Or it's the degrees?
No, it's like because I put this is like the length of the list because when I call this function, I start to search
Right.
check every last, and if the list have more than 55 point, for me it's like still is a wall,
All right. So
and
so
mhm.
does it have to be 55 matching points, or because remember your LiDAR, right? It always has values,
Mhm.
right? It always has values that are greater than 55, right? So when you say
Yeah.
55, what are you looking at? Are you looking at values that are within a certain threshold
No,
or
no, the
distance value?
the length, no, no, the length of the list of this list.
Okay, okay. All right, all right, all right. So
So because if like, mhm.
what I'm getting from this is that you're doing some multimodal filtering, right? So depending on how many modalities you've got, you are filtering for anything that is mods less than 55.
Yeah, yeah.
Okay, okay, all
At that
right.
point is like a wall.
Okay, okay. I think I see where you're going with this. All right, let's go on.
Okay, and and after this, I start to to analyze just the valid range that we found before with the leader
Mm-hmm.
and with the function, and I start to compare the different distance and find the global minimal distance. And when I found the global minimal distance, I use the control effort to go to this go to the minimum distance, so to the
Okay,
wall.
okay, okay.
And this is for like the first step. So find the minimum distance, go to the wall, and after in the third step, I start to see the rotate the robot because using the leader and the motor
Mm-hmm.
to rotate to align with the wall.
All right, all
And
right.
for okay.
Yeah, you can go on. You can go on. I was going to ask you a question, but I realized you had not finished.
Okay. And after this, I changed the script, and I will go to the script there where we use this controller that is here, where we have the condition, and for each condition I give a control effort, where this distance is the distance using the that I calculate through the lidar. As like this distance is less than 50 centimeter, I do this. Otherwise, I do this and
Mm-hmm.
go next.
All right.
And yeah, this is more or less the code.
Okay, so can you explain to me how do you control which one, which script is executing and which one takes, how do you, let me say, how do you transition from wall finding to wall following? Can you show me where that,
Yeah,
wait,
yeah. So the wolf following is like the main script because
mm,
I call the actions server
mm-hmm,
using the action client that is here,
mm-hmm,
and using this I can sorry, the server, not the action, the server, and with this I start to follow the wall. So when finish like the wall finder script, it
right.
continues with the wall following.
Okay, okay, all right. Very well done on that part. So, one thing that I also want to understand, so can you take us a bit more
Mhm.
through how do you ensure a constant distance from the wall, right? So obviously you have to follow the wall at about between
Mhm.
0.25 and 0.35, right, from the wall.
Yes.
So are you just using that if else statement or you have any other controller that's going on?
So for for this distance, so for the front distance, I create like a cone, and so I don't just see like a single laser,
Mm-hmm.
but take in consideration more laser. And instead for the right distance, I use just one laser because was enough. I saw that the script work enough, so I
Mm-hmm.
didn't create one for the right distance. But for sure, if you want more robustness code, it's better to create also a cone for the right distance.
Very nice, very nice. Well implemented. All right. So other than the things that we have spoken about, which is discovering the wall and making sure that your robot does not perceive obstacles as walls, what other challenges did you encounter?
But so you want no other challenge?
Yes. Did you have any other
For
issues or
sure, yeah, yeah, for sure. Like when I pass from simulation to real world,
right?
there's every time there's some problem. For example, I remember when I start to launch my script
Mm-hmm.
that need to find the nearest wall. In the beginning, doesn't work, didn't work because there's like this stick that the robot has,
Mm-hmm.
and in the simulation doesn't have this stick, and so the minimum distance was every time was this stick, but this took me some time to understand that the problem was the stick. In the beginning, I thought other things. So for sure, another challenge was to understand that the stick was a problem for the leader.
Mm-hmm. And how did you deal with that issue?
I removed like I like put a minimum distance that if like the leader calculate this minimum distance, we can ignore that laser because I take like a 15 centimeter. That is more or less the dimension of the robot.
Mm-hmm. Mm-hmm. So anything that was within that radius you didn't consider to be an obstacle.
Yeah,
Okay.
yeah,
Okay.
yeah, because it's like yeah, the dimension of the robot.
All right. What about the obstacles that are a little that are movable, right? For example, the road signs
This
that we've
obstacle,
got.
like
Yes. Did you have any issues with those? And how did you deal with them?
mm, really not, because every time this obstacle is very near to the wall.
Mm-hmm.
So usually the robot don't touch the doesn't touch the this obstacle,
Mm-hmm.
doesn't hit, because also the robot stay 30 centimeter from the robot, sorry, from the wall, and so yeah, no, I don't have problem with this obstacle.
Okay. So I assume that most of your testing you did when the with the obstacles pushed to the side or not in the middle
Yeah,
of
yeah,
the.
yeah, yeah.
All right.
Yeah, yeah. No, in the middle, no.
All right. So what I'm going to ask you is if you were going to alter your script to be able to deal with having those in its way, how would you deal with it, right? On the top of your head, just tell me how you think you would deal with it.
Like how to avoid this obstacle.
Yes. So obviously you want to have you want your robot to have awareness of where the wall is, but at the same time not crash into those things while it's following
Mm-hmm.
the wall, right?
Yeah, maybe we can use like we can create different cone using the leader,
Mm-hmm.
and that way we can avoid the obstacle because more or less we have 360 degree that so the leader cover every side, so we can use the leader, and that way also uh, we can avoid the obstacle. For sure, the best things is like implement a real control, like a better intelligence control. I don't know, a smart controller,
Mm.
like for example, a model predict control or a reinforcement learning. And also maybe we can use like because I know there is like some library that ROS2 use like the navigation library that we can scan the entire map, the entire environment. And so because also this obstacle is like static, it's not dynamic, so we can like create a map for this obstacle, and we know more or less the position and we can avoid.
Mm-hmm.
I think
Okay.
like there is a lot of possibility.
All right. Yeah, yeah. A bit of advanced methods there, but I
Mhm.
just wanted to be I wanted it to be general answer. Maybe you'd say maybe you'd speak somewhere in the lines of the kind of states that you'd use, but I think you already spoke about this, which is you would make the algorithm maybe a bit more intelligent, but for the purposes of the task, that was not required. I was just trying to
Mhm.
get us to talk about this to maybe understand a bit more the complexities that we may encounter in the process of having it follow the wall. But for the purposes of the task, this was a job well done, and thank you very much, Valerio. So what we're gonna do is we're gonna wrap up our conversation here, and then we will finish our recording. All right, everyone. This was Valerio's presentation, and a warm congratulations to him. I'd like to encourage all those of you who would want to try this course to also do so, and you can come and showcase your work. So until next time, keep pushing your learning. Bye bye.